in the middle of the ocean, far from any shore, engineers dared to build the impossible.
This is the world's most terrifying lighthouse.
The CAD design is finalized. Let's run the wave simulation.
With the design locked in, every number had to be perfect before a single bolt was placed.
Look at the stability metrics here. They align perfectly with the projections. The wave test results were solid, but the real ocean would be far less forgiving.
This high-density marine concrete, fortified with basalt aggregate, would become the lighthouse's first line of defense.
The basalt aggregate is mixed in, reinforcing the concrete against the relentless punishment of rogue waves.
We need to reinforce the foundation against the rogue waves. Mixed ratio confirmed.
Every batch was tested to its limit before a single drop reached the sea.
Building the world's most terrifying lighthouse begins here, deep in the moon pool.
Watch the alignment. Easy now. All right, man, watch the swing radius. Keep it steady.
Every centimeter of descent was controlled by hand and machine, working as one.
Copy that. The load is secure. Proceeding with the drop.
What happened beneath the surface would determine whether this lighthouse stood or fell.
Control to bridge. Dynamic positioning reports green status. We are locked on target.
Roger that. Proceed with Phase 2 deployment.
Holding position on the open ocean with no anchor is an engineering feat in itself. The first step was securing the foundation, a massive tungsten drill bit boring anchor holes directly into the ocean floor. Deep beneath the waves, the drill carved the lighthouse's grip into bedrock. Fabricating the tower blocks on land minimizes risk at sea, but the scale of these segments presents its own challenges.
Each block had to be perfect before it ever touched the water.
High-strength marine mortar is troweled precisely into the joints, sealing the blocks against the relentless force of ocean waves.
Hold it steady. We are easing it down now.
At any moment, a rogue wave could claim years of work and endanger every life on board.
Nothing could be left to chance. Nothing could be left to chance.
At the bottom of the ocean, precision is measured in millimeters. This is the most terrifying lighthouse ever built. Getting these segments to align in the middle of the ocean required brute precision and relentless human will. Against the backdrop of an incoming storm, the second tower block was carefully maneuvered into position.
Hold it steady. Watch the east side.
Okay, lower it slowly. Slowly now.
Bring it up slowly. Watch the starboard side.
Okay, easy. Now set it down.
The intermediate floor casting requires precision. Fiber-reinforced concrete is poured and leveled before curing begins. Every floor had to be perfectly level.
A bubble out of true at this height would compound all the way to the top.
The swell on the starboard side. Keep lowering steady. We are aligned.
Coming down now. Close 36 hours, that's up.
Building in the open ocean presents unique challenges. Here, the floor slab undergoes its crucial curing phase, hardening against the elements.
The engineers apply a thick resin coating, locking in the carbon fiber reinforcement. Not a single void could survive inspection.
The laser alignment ensures millimeter precision as the segment settles into the wet mortar layer.
In the open ocean, a millimeter of error is the difference between standing forever and failing in a storm. In the middle of the unforgiving ocean, installing massive wave deflectors was a terrifying but essential feat of engineering. Each deflector was engineered to force rogue waves around the structure, redirecting thousands of tons of force rather than absorbing it.
The structural integrity of the fourth segment is critical.
Everyone, safety lines clipped.
Forcing the engineers to work despite the rising gale.
Woo! Character B, tie down those pipes.
The crane is holding steady, but the wind is rising.
The fast-curing sealant was essential for the emergence joint sealing, allowing them to finish just moments before impact.
Moments before the storm hit, the seal was complete.
Hear that? Cure rate is optima.
All right, let's move on to the exterior cladding.
The exterior cladding was applied one massive slab at a time, each piece a shield against the ocean. Workers meticulously tighten the concealed anchors behind the massive stone slabs, ensuring each panel is locked permanently in place.
Casting the upper floor required precision. High above the churning Atlantic, there was no room for error.
The team begins the critical pour capillaries, dozens of meters above the ocean, in wind and spray.
Pull hard on the left line B. We have to counteract the sway. Copy that. Ready for descent.
Attention releasing now. Confirm, looks good.
Torque check on joint 4. Reading green. Moving to the next segment.
The next challenge was casting the lantern room base using ultra-high-strength concrete.
This was no ordinary concrete mix. Each segment was lowered through the open lighthouse shaft.
The central shaft required the installation of massive spiral staircase segments, and
finally revealed the massive Fresnel lens, the heart of this formidable structure.
A testament to engineering against the elements.
Bring it down slowly, watch the alignment.
We have contact. Start securing the bolts. Now.
Meticulously applying the silicone seals. One unbroken line. No gaps. No water. The lantern glazing process requires millimeter. These thick, curved glass panels are lifted and seated one by one.
Calibration complete on the secondary array. Let's take it to full power.
Power leads connected. We are initiating the sequence now.
Confirmed.
Calibration sequence active.
To power the world's most terrifying lighthouse.
The ocean that threatened to destroy this structure would also power it.
The readings are perfectly stable at full rotation. Confirmed. The analysis is complete.
Built, sealed, powered. The world's most terrifying lighthouse was finally alive.
That's the last section. Looks solid. Let's secure the gear. Radios are secure and labeled. Checklist updated.
Good. Proceed to the main control panel for the final systems test.
In the middle of the raging ocean.
Systems running at 80%. We have a warning light on Sector 4.
Push the override. It's stabilizing.
Test complete.
Test complete.
The strain gauges spiked dramatically under the load.
All right, the load test is complete. Good. Let's get this rig stowed before the storm hits.
Structural drift is 0. We are stable.
Confirmed. Proceed to load testing.
The displacement is exactly within tolerance at peak load.
Excellent. The design holds.
With final engineering approval.
Systems verified.
Main switch engaged. Power flow nominal. Rotation speed increasing. Beacon status active.
We are fully operational.
Safety protocols finalized.
All personnel, emergency evacuation. Proceed to the docks.
The crew evacuated, leaving the structure to face the ocean alone.
The system switches to autonomous mode.
From the moment of activation.
Visibility check successful.
Look at the resonance frequency graph right here. Perfectly stable. Incredible.
Confirmed and logged for the final report.
Built in the middle of the ocean.
To confirm stability, the structure must withstand the ocean's full fury.
As you can see, it remains completely unmoved.
Not a tremor. Not a crack. The engineering had triumphed. Again and again, the ocean tested it. Again and again, it held.
Deep below the waterline, the foundation gripped the bedrock, just as the engineers designed.
Life was already returning to the structure, the ocean adapting to what engineers had placed within it.
At its heart, the lens turns.
From here, on the most dangerous stretch of ocean, the light guides ships safely past.
This is what it looks like to build the impossible. Every element, every decision, every pour and weld and see.
The fleet left.
For the engineers, this was more than a structure. Proof that human ingenuity can plant a permanent mark.
Every rotation of that light is a message to the sea. We built here. Every seal, every joint, every layer of defense, exactly as the engineers designed.
4 layers between the ocean and the structural core.
Rogue waves. The lighthouse was built for this. Not once did the beacon fail.
From shore, engineers monitor every reading in real time. Trade, structural load, beacon status, power levels.
Look at the resonance frequency graph right here. Perfectly stable. Incredible.
Every ship that passes safely is a vindication of every decision made in that engineering studio.
What began as a CAD file and a scale model became the world's most terrifying lighthouse.
The ocean tried to break the model. It couldn't. The real thing never had a chance of failing. From the ocean floor to the lantern room, 43 meters of engineering against the elements.
Level by level, pore by pore, it grew.
Their names are in the stone. Their work is in every wave that crashes against it.
Inside, it is calm. Outside, the ocean never stops.
The joints that once held together in wet mortar and storm wind, now set for 100 years.
To a sailor in a storm, this light is everything.
Engineered to be seen for miles, through rain, through fog, through fear.
On a rare, quiet day, you can almost forget what it took to build this.
The storm always comes back, and every time it does, this structure answers. The foundation that was drilled and grouted into the ocean floor holds everything above it, and everything above it holds the light. In zero visibility, the light does not stop.
Every system was designed for the worst case. The engineers never assumed the ocean would be fair.
It didn't. Every inch was taken. Every inch was earned. Inside the world's most terrifying lighthouse, the light turns, and the ocean watches.
Engineers faced immense challenges building it in the middle of the ocean.
They built it anyway.